Hi, I'm Eric Roden.
And I'm Ray McCormack, and we're the publishers and editors of Urban Firefighter magazine.
We'd like to welcome you to this segment of Fire Engineering's Training Minutes filmed at FDIC 2011 Hands-On Training Program.
These training minutes are based on the Urban Essentials Hot Class, the largest hot class at FDIC. Come visit us at urbanfirefighter.com.
Hi, welcome to Training Minutes. I'm Lieutenant John Ceriello from the New York City Fire Department. This segment, we're going to take a look at the High-Rise Nozzle, a device that enables the fire service to get water onto a fire in a high-rise building when we're out of reach of any exterior streams, be it from a tower ladder or the ground or an adjoining balcony. Let's take a detailed look at this device. If we look here, it is roughly an 8-foot long piece of 1.5-inch tubular aluminum. On this end, we have a simple 2.5-inch ball valve. Here we have a T-handle welded in place. It gives us some maneuverability of the nozzle when it's in place, flowing water into the floor above where the fire is located. Here we have a trussing system which gives rigidity to this pipe because we're going to get a tremendous amount of downward force when the nozzle is flowing. That keeps it nice and tight and allows us to control that stream. At the far end, at the tip, we have an 1.1/8 tip. So with the 2.5-inch line, an 1.1/8 tip, that's the same combination of hose and nozzles we use in our standard high-rise packs. It also won't allow any clogging factor to occur. Also in our testing on Governor's Island in 2008, we actually found that the solid bore tip flowing in and hitting the ceiling of the fire room, basically turning on a sprinkler head, knocked the fire down rapidly, cooling everything downstream. The fog tip was not as effective as a solid bore tip. The high-rise nozzle is 14 pounds. It's easily transported in elevators and up stairwells. To deploy the high-rise nozzle, the engine company simply has to place the nozzle on the windowsill, give it a slight tilt to one side, and when ordered, open the nozzle. The water will begin to flow, hitting the side of the building adjacent to the window. Slowly, that company will push the nozzle out and at the same time begin to bring the nozzle square up, pointing straight up. The stream now should be hitting the spandrel wall between the floor below window and the fire window, or the target window. At that same time, with the water hitting the spandrel wall, it will rain down and you'll hear the actual nozzle or the stream hitting that spandrel wall. You continue to push out till the sound disappears and the water is no longer raining down. At that point, you know that the stream is in the window, hitting the ceiling above the fire, knocking the fire down. The engine company can also wiggle the nozzle, which will disperse more water in the fire area. After roughly 30 seconds, they can then shut down, and as they shut down, slightly tilt the nozzle to the side so a water slug does not hit them on the floor below. And then we look for conditions on the fire floor if they've changed and we've knocked the fire down. There will be times a direct frontal attack will not be capable in these type of buildings, in high-rise buildings. So this device will actually allow us to get some water on the fire from the floor below, again, making for a much safer operation in these type of challenging fires. I'm Lieutenant John Ceriello. Thank you for watching Training Minutes.